Mohammad Isaac and hope everybody is doing good. So let us start a physics class today. So we will start a new chapter, chapter number 2, motion. Okay, so chapter number 2, motion. So firstly we'll see the introduction about motion. So we have a question over here is how can you tell whether the object is at rest or at motion? Okay, how can you declare a certain object is at rest or motion? So for that, firstly we'll have to see the terminologies or definition of rest and motion. So let's see. So rest. So we can call it as state of rest. Okay, we can also call it as state of rest. When the position of the object with respect to the objects around it does not changes, okay, then we call it as a rest. Okay, the object is at rest. So I'll repeat it again. When the position of the object with respect to the objects around it does not changes, then we call it as then we say it the object is at rest. Okay. So for example, let us consider this is a table. Okay, and here is a book. Here is a book. Now let us consider there is one glass over here beside the book. One glass beside the book. So this glass is not moving, and not even the book is moving. We have to consider the surrounded objects. So this is my observing point. Okay, this is my object. So around it there is book and a table. So with respect to book and table, it is not changing its position. It is initially at this point and it is in the same point. It is not changing its position. So at this point I can say that this object is at rest. Similarly for the book, if I consider if my observing point is on the book, with respect to glass and book, which are the surrounding objects of the book is not moving. Okay, it is not changing its position. It is at the same position. So I can say that this is at rest. Okay, the book is at rest. Now, what is motion? Okay, so for motion, we have when the position of the object with respect to the surrounded objects does changes. Okay, it changes. Position will change when the position of the object with respect to the objects around it changes or moves. Okay, moves or changes, then we can say that the particular object is at motion. Okay, so let us consider the same example. So let us consider I am applying some certain amount of force on the glass. Okay, I am applying some certain amount of force on the glass in this direction. Okay, I am applying certain amount of force. So the glass is changing its position from the initial point over here. It is moving to this point. Okay, so this is the point B, position B. So from after applying some certain amount of force, glass is moving from this initial point to this final point. Okay, it is moving. So how can you tell that it is moving? See, when you consider the surrounding objects like book or this table, it is changing its position. Okay, according to the book and table, it is changing its position. So I can say that this glass is at motion. Okay, so now I can say this glass is at motion. Okay, I hope you understood about the introduction part. So now we have a question that what is relative? Okay, and how it is related to motion and how it is related to motion. So for this I'll tell you one thing. See, we can create any sentence using some words, grammar, or some sensible words. Okay, we can create a sentence, but if there is no relative relation between those sentence or words, between those words, there would be no meaning for the sentence, right? There should be some relativity between the words to have a meaning for the sentence. Okay, there should be some relativity between the words to have a meaning in the sentence. So for this, I'll explain you one thing. See, what if I say water is triangular? Okay. See, I am saying that water is a triangular. So I am creating a perfect sentence. It is a perfect sentence. It has noun and it has objective adjective also. But does it make any sense? Water is a triangular. It doesn't make any sense. This sentence doesn't make any sense. So there should be some relativity between the words. There should be some relativity between the words to have a perfect meaning. So similarly, if I write instead of triangular, if I write the water is clean. See, what if I write the water is clean? So there is a relation between the sentence, relativity between the words, and also it makes a perfect meaning. Okay, it makes a perfect meaning. So this is about the relativity. It must have a relativity between the sentence to create a meaning. Similarly, in terms of motion, there should be a relativity. Okay, there should be a relativity between the motion. See, for this I'll tell you one example. See, right and left. Okay. So right and left. Let us just consider this is a road. Okay. Let us just consider this is a road and there is a house over here at the center. Okay. Let us consider this is a house. So let us consider one of your friend is coming in this direction. Okay, he is walking in this direction, and one of the person is moving opposite. Okay, opposite to him. So now can you tell which side of the road is the house? Okay, can you tell it? So let us consider him as A and this boy as B. Okay. So now, according to him, he's moving in this direction, which means the house is at the right. Okay, house is at right of his. According to him, the house is at right position. According to him, but if I consider for him, the house is at left. Okay, the house is at left. The position of the house is not changing, but it depends upon the observer that how they view. Okay, so he is walking towards this direction, which means towards his right is the house. He is walking in the opposite direction. Towards his left is the house. So it depends upon the observer how the object is placed and how the position of the object is. Okay. So I'll give you one more example for this. Is day or night? Okay. Is day or night? See, can you ask someone like whether it's a day or night without referring a particular place? Okay, without referring a particular place, can you ask them like what's like is it a day or night? Can you ask them? So it is not possible. So you have to refer a place name. See, in Hyderabad, it is day. It is day now. But in New York, it is place before questioning somebody that is it a day or night. Okay. So there is a relation between day and night. Okay, there is a relativity between day and night. I hope it is clear to you guys. Okay. So now we'll see about up and down. Okay. So how the relativity between this thing. So this is Earth. This is nothing but Earth, and we all know that Earth is a spherical ball. Okay. Earth is a spherical. So the person living over here will be upward. Okay. And similarly, if he is over here, he will be on top of the land. Okay. He will be not a slanted one. Okay. He will be on top. Similarly over here, he will be on up the land. Similarly over here, he will be on the up of the land. See, now you shouldn't consider the person from here to here. You are not supposed to consider these two positions of the persons at together. Okay. So you have to consider the surrounding objects. Okay. You have to consider the surrounding objects over at this position. Okay. For this, you have to consider the surrounding objects over here, not somewhere around there. Okay. You have to consider the surrounding objects over here. So this is how you get the relativity. Okay. Between this. Okay. Between this motion of the objects. Okay. So now let us see how the relativity will be in the motion. Relativity or relative motion. Okay. So relative motion. See, for this I will give you an example. So let us consider this is a road and there is one car. Okay. There is one car. So one of the person is sitting in the passenger seat and one of them is a driver. Okay. Let us consider this is a car on the road. And let us even consider one of the person is standing and he is A and other one is standing beside him is B. Okay. A and B are facing each other and they are standing at this particular points. They are not moving. They are at rest. Okay. They are at rest. So now let us see, like my observer would be a A. Okay. According to him, he is standing. He is not changing his position according to some objects. Let us consider a tree. Okay. According to this tree, he is not changing his position. So which means according to A, B is at rest position. B is at rest position. Similarly, according to B, if B is my observer, he is not changing its position, right? He is not changing its position according to some house over here or something. Okay. He is not changing its position. So which means even A is at rest. Even A is at rest position. Now let us see, even now my observer is A and now he is seeing the car. Okay. He is observing the car which is moving in this direction. The car is moving in that direction. So according to him, the car is moving. Along with the car, the persons inside the car are moving. Okay. According to him, according to this observer, is moving. So which means it is a motion. Even the person sitting inside are at motion according to A. According to A. Now let us consider my observation. Yeah, my observer is a passenger. Okay, a passenger in the car. So according to him, is he moving? Okay. According to surrounding objects, like consider a seat over here. Okay. So according to seat, is he moving? according to this observer, he is at rest. He is at rest. See, though the car is moving, but the person inside the car is not moving. Okay, the person inside the car is not moving. So similar way, if the driver observe the passenger with respect to some seat or something over there, the object over there is not moving. It's not moving. It's stable at his position, which means he is also at rest. He is also at rest. Okay. So now if they see outside the car, okay, they are seeing outside the car, the A is standing over here. If they watch the A and they are moving, though they are at rest, they are standing at still position, but according to the car is moving. So which means the distance is increasing. So according to them, he is at motion. See, I'll explain you again. See, my observer is a driver over here. Driver is watching a person A who is standing at rest position according to this. But the car is moving. Which means he will be the distance would go on increases. The distance will go on increases. So according to him, he will appear it as in motion position, in motion state. Okay. Though he is standing, according to the observer, he will be in motion because car is moving forward. So whether it's a motion or not, it depends upon the observer, how you see it. Okay, how you see it. I hope it is clear. Thank you. So now let us discuss about the distance and displacement. Okay, so what is distance? It is the length of the actual path traversed by a body between its initial and the final position. Okay, between its initial point and final point. Okay, so for this I'll give you one simple example. So let us consider this is your starting point A. Okay, let us consider this is your starting point A, and you are moving in this direction at B. Okay, this is a point B, and you are moving the north at C. Okay, so this is your initial point A and this is your final point B. Okay, so traveling between the initial point and the final point is known as distance. Okay, the length of the actual path traversed by a body between its initial and final position. Okay, traveling from A initial point to this final point C is known as, the length is known as a distance. Okay, this length is known as a distance. Okay, now what is displacement? The shortest distance moved by the body from initial point to final point. Okay, the shortest distance moved by the body from initial point to final point. So let us just consider the same figure. This is a point A, this is a point B, and this is the final point C. This is my final point C and this is my initial point A. The shortest distance, what would be the shortest distance? Okay, apart from going like in this direction, I can move directly in this direction. So this is my shortest distance. The shortest distance between the initial point and final point is known as displacement. Okay, is known as displacement. I hope it is clear. If we are considering the length, between initial point and final point, it is known as a distance. If we are considering the shortest path, it is known as displacement. Okay, I hope it is clear to you guys, and thank you.